In the in 6.4 day 1, if we take a look at the top, it says a rational function is any function which can be defined by a rational fraction. For example, an algebraic fraction such that both the numerator and the denominator are polynomials. What do you know about the denominator of any fraction? Well, the answer to that question is that the denominator can't equal 0. So graphs of rational functions will have asymptotes where the denominator equals 0. Next thing you need to know is how to find an x-intercept, and that's the same for every single function. If you're looking for an x-intercept, you're going to set y equal to 0 and then solve for x. And then how do you find a y-intercept? Well, a y-intercept, again, for any function, it's the same way. We're going to put 0 in for x, and we're going to solve for y. So let's take a look at example 1, where we're going to match graphs of rational functions. So we are going to consider two rational functions, these two right here, f of x and h of x. And what we want to do is we want to match them with the graphs below. So I'm going to move this up just a little bit more. All right, that should be good. Now, if I take a look at f of x, I'm going to rewrite this function f of x by looking at factoring the denominator. So my numerator is going to stay the same, 3x minus 6. And my denominator, if I factor that, is x minus 4 times x plus 2. So if I take a look at that being factored in the denominator here, remember that can never equal 0. And when it does equal 0, that denominator, then I'm going to have these asymptotes. So if you can see these little dotted lines in these graphs, those are your vertical asymptotes. So if I set this equal to 0, that gives me my vertical asymptotes. So I can say for f of x, my asymptote I have as x equals 4, and I have an asymptote of x equals negative 2. Again, that came from setting that denominator equal to 0. The other thing that's going to help us, well, let's actually go through, and we can kind of X out some of these graphs already. So if I take a look at graph A, I need an asymptote of 4 and negative 2. Well, this one has an asymptote, looks like 3 and negative 1. So that does not work, so I'm going to take that graph out. If I take a look at graph B, I have asymptotes at negative 2 and 4. So graph B is still a possibility. If I take a look at graph C has asymptotes of 3 and negative 1. So that won't work, so I'm going to cross that one out. If I take a look at graph D has asymptotes at negative 2 and 4. Still a possibility for me, so I'll leave that one. Graph E has asymptotes at negative 1 and 3. So that one won't work, so I'm going to cross that one off. And graph F has asymptotes at negative 2 and 4. So far I've eliminated 3 graphs just by looking at the asymptotes. Another thing that I can help is the y-intercept. So where is it crossing over the y-axis? So I'm going to find my y-intercept. And remember, the y-intercept is found when x is equal to 0. So that means I'm going to have the point 0, comma, something. If I come to my function over here, and I plug 0 in for my x's, that's going to take away that part. It's going to take away anything with an x in it. And all I'm left with is negative 6 over negative 8. Negative 6 divided by negative 8 simplifies down to 3/4. So I know I have a y-intercept of 0, 3/4. So if I look at graph B, I need to be crossing over right before the 1. And I don't. I have a negative y-intercept. So this graph won't work. If I take a look at graph D at my y-intercept is very close to negative 2. Again, it's a negative y-intercept, so that graph won't work. If I take a look at graph F, and I look at my y-intercept, you can see that it's touching right underneath the positive 1, which tells me that it's probably pretty close to 3/4. So graph F is going to be the graph that we want. So f of x is graph F. Then we want to take a look at h of x. If I take a look at h of x, I'm going to do the same thing. I'm going to go ahead and factor the denominator. So I have a 4 over x minus 3 times x plus 1. And then what I want to take a look at are my asymptotes. So if I take a look at the asymptotes by setting the denominators equal to 0, I get asymptotes at x equals 3 and at x equals negative 1. So if I start eliminating some of my graphs, graph A I have negative 1 and 3, so that's a good choice. Graph B has negative 2 and 4, so that one won't work. If we take a look at graph C has asymptotes at negative 1 and 3, so that's a possibility. If we take a look at graph D, our asymptotes are negative 2 and 4, so that one won't work. And then if we take a look at graph E, we have asymptotes at negative 1 and 3, so that's still a possibility. And graph F, we have it at negative 2 and 4, which will not work. Then let's go ahead and find our y-intercept. So our y-intercept here, remember, is still when x is equal to 0, so we need to find that y-coordinate. So if I look at my function and x is equal to 0, that's going to cross out anything with an x, and I'm going to be left with this fraction, which is negative 4/3. Negative 4/3 is just a little bit smaller than negative 1. So if I go ahead and look at the graphs I have possible, graph A has a positive y-intercept, so that won't work. If we take a look at graph C has an intercept just below negative 1. So let's double check and make sure graph E does not work. So if I take a look at graph E also looks... Oh, no, graph E is way below negative 2. So since graph E, let me move this up a little bit. Graph E is below, below negative 2, which is going to be a lot smaller than negative 4/3. So graph E is out, which means graph C is our correct solution. If you go ahead, there's a try this on the next page. So go through that, try this, and then you can check your answers when you're ready. So go ahead and hit pause. If you did this one correctly, you should have gotten B for f of x and A for g of x. If you have any questions, please let me know and I'll help you.